Venn diagrams and probability. In this video we will look at Venn diagrams and the probability associated with them. On the right hand side are all the probability formulas in the formula booklet. The sort of questions you will get with this type of diagram are: what is the probability of A? Well, if you look at the Venn diagram, the probability of A is everything in the circle marked A. So in this case, it is 0.4 plus 0.2, which is 0.6. You might also be asked, what is the probability of B? Well, that is everything in the circle marked B, which is 0.2 plus 0.3, which is 0.5. You might also be asked, what is not in A, which is represented by an A with a little dash, and that is equal to everything that is not in A. So that is 1 minus the probability of A, which is 0.6, so it is 0.4. If you go to the formula part, that is the complement formula, which is written slightly differently, but if you rearrange that, the probability of not A is 1 minus the probability of A. You might also be asked, what is the probability of A intersection B? And the intersection also has another word associated with, that means and. So that is everything that is in circle A and in circle B. And if you look at the diagram, this is this little bit. So it is equal to 0.2. You may also be asked, what is the probability of A union B? And the union also has another word associated with it, and that is or. So this is the probability of what is in A or in B or in both. And that is everything in A and everything in B. So that is equal to 0.4 plus 0.2 plus 0.3, which is equal to 0.9. You may also be asked, what is the probability of A union B not? And that is equal to everything that is not in A union B. So that is equal to 1 minus what is in A union B, which is 0.9, which is equal to 0.1. I want to take a closer look at one of the formulas, the one for combined events. And that says that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. This formula sometimes confuses a lot of people because you've got this subtract the probability of A intersection B. And why is that? Well, if you take a closer look, the probability of A, everything there, and the probability of B intersection there, if you add both of those together, the intersection here is counted twice. So that is why the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. A typical IB exam question is the one shown. The following Venn diagram shows the events A and B, where the probability of A is 0.3. The values shown are probabilities. Part A. Find the value of P. We are told that the probability of A is 0.3. So that means everything in A is equal to 0.3. So the probability of P is equal to 0.3 minus 0.1, which equals 0.2. B is equal to 1 minus 0.1 minus 0.2 minus 0.4, which is equal to 0.3. And part C, you've got to find the probability of not A union B. That means you want the union of everything that is not in A with everything that is in B. So let's draw a little diagram or shade in what they mean. Let's draw a little diagram to represent the probability of not A union B. So it's everything that is not in A, which is here, unioned with everything that is in B. So it is everything except this little part here. So this part is not included. So let's make that diagram a little easier to understand. So we want everything that is not in here. So therefore we want everything that is in this section here, which is equal to 1 minus 0.1, which is equal to 0.9. Question 2. Consider two events A and B such that the probability of A is equal to the probability of not A intersection B, which is equal to 0.4, and the probability of A intersection B is equal to 0.1. By drawing a Venn diagram or otherwise, find the probability of A union B. So if you draw a Venn diagram, label your known probabilities. Well, we know that the intersection of A and B is equal to 0.1. We also know that the probability of not A intersection B is equal to 0.4. Well, this is the section here. So that is equal to 0.4. So we're also told that the probability of A is equal to the probability of not A intersection B. So the whole of A is equal to this section of B. So this section of A must be equal to 0.3. 0.4 minus 0.1. We can now answer the question. The probability of A union B is equal to 0.3 plus 0.1 plus 0.4, which is equal to 0.8. 2b. Show that the events A and B are not independent. There is a formula for independence which is as follows. For two independent events, the probability of A intersection B must be equal to the probability of A times the probability of B. To test for independence, see if this formula works. The probability of A is equal to 0.4. The probability of B is equal to 0.5. So the probability of A times the probability of B is equal to 0.4 times 0.5, which is equal to 0.2. But the probability of A intersection B is equal to 0.1, therefore not independent.